Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for the upcoming test on equations. So the way that we solve these types of equations called linear equations, where the x has no power attached to it, we get the pronumeral to one spot and then undo everything that has been done to the pronumeral in the opposite order to BIDMAS. So in this equation here, we have x being multiplied by -5 and then 34 has been added. This is a positive 34. We did it in that order because of BIDMAS. We multiplied then added. So when we're solving, we need to do things in the opposite order to BIDMAS. So because adding 34 is the last thing we did, it's the first thing we undo. It's just like in the morning, you put your socks on first, then your shoes, and at night, because your shoes were the last thing you put on, they're the first things you need to take off. So it is here. So we undo adding 34 by subtracting 34 because they undo each other. Now the golden rule with equations is what you do to one side of the equation, you must do to the other. So because we subtracted 34 from the left-hand side, we must also subtract 34 from the right-hand side. So our next line of working is -5x equals -25. Now we undo timesing by -5 by dividing -5. Divide and times -5 undo each other. Now we've just got x by itself. But what we do to one side of the equation, we must do to the other. So -25 divided -5 is 5. Our final answer is x equals 5. So this is the solution, because if I take my equation, 34 minus 5x equals 9, and I substitute x for 5, I get a true statement. 34 minus 25 equals 9 is a true statement. So I know x equals 5 is the solution. Now you should always check your equations this way. If you get a solution, substitute it and make sure it makes it a true statement so you know if you're right. All right, let's look at this example here. So here we have a fraction. So to get rid of the fraction, to undo dividing by 7, I'm going to times by 7. But when you times one side by 7, you must times the other side by 7. Now, when I times this side by 7, I have to times everything by 7. I have to times the x by 7. I have to times the fraction by 7. So times 7 and divide 7 undo each other. And then I have to times 9 by 7. So when we're solving equations, we need to get the pronumeral to one spot. So 7x minus x is 6x. I need to get x to one spot before I can use the process from the previous example. Now that x is in one spot, I undo what's been done to x in the opposite order to BIDMAS. I'm going to subtract 15 from both sides because plus and minus 15 undo each other. I'm left with 6x equals 48. Then I undo timesing by 6 by dividing each side by 6. The answer I get is x equals 8, and you can easily check. 8 plus 7 over 7 does equal 9. It gives me a true statement. All right, let's now look at equations in which the pronumeral is on both sides of the equal sign. So when you have such equations where the pronumeral or letter is on the left and the right hand of the equals sign, follow these steps. Expand any brackets or get rid of any fractions. Subtract from both sides the pronumeral with the lowest coefficient, then solve as normal. So what do I mean by that? Well, let's look at this one here. X is on both sides of the equal sign. So there are no brackets or fractions to get rid of. So I'm going to go straight to step 2. I'm going to subtract the one with the lowest coefficient, i.e. lowest number in front. This one has the lowest coefficient. 7 is lower than 10. So I'm going to subtract 7x. What you do to one side, you must do to the other. 7x minus 7x undo each other. So on the right hand side, 10x minus 7x is 3x. I get 3x plus 5 equals 32. What I've done is I have made it so x is only in one spot. Now I can solve as normal. I can undo what's been done to x in the opposite order to BIDMAS. So that would be subtracting 5. So I get 3x equals 27. And then we undo timesing by 3 by dividing by 3. What you do to one side, you must do to the other. The answer is 9. 10 times 9 plus 5 is 95. 7 times 9 plus 32 is 95. You should always check your solution. All right, let's look at this one here that also has x on both sides of the equation. So there are no brackets or fractions to get rid of, which is good. So I'm going to go to step 2, subtract the pronumeral with the lowest coefficient. This is 3x, this is not 3x. This is actually negative 3x. Negative 3 is lower than 3. So what I'm going to do is subtract negative 3x, which is the same as adding 3x. Subtract 3x and add 3x undo each other. But what you do to one side, you must do to the other. So here I'm going to have 8 equals 6x plus 32. Now we solve as normal now that x is in only one spot. We are going to subtract 32 from both sides. So we get negative 24 equals 6x. Then we're going to undo timesing by 6 by dividing 6. What you do to one side, you must do to the other. The answer I get is x equals negative 4. Once again, you should substitute into your original equation and check if it's correct. All right, let's look now at a harder example of an equation. So we're going to solve this equation here that has pronumerals on both sides. So this time I do need to do step 1. I need to get rid of any fractions or brackets. The way you get rid of a fraction is by timesing. So the way I'm going to get rid of this fraction is by timesing each side by 4. What you do to one side, you must do to the other. Now, when I times this side by 4, I have to times everything by 4. You're timesing 4 by the whole lot. So 4 times 10 just gives us 40. When this is timesed by 4, the times 4 and divide 4 cancel each other out. I'm left with subtract x minus 3. On the right-hand side, when you times this fraction by 4, you only times the tops. So I get 4 lots of x plus 11 over 5. Now I'm going to get rid of this fraction by timesing 5, because times 5 and divide 5 undo each other. What you do to one side, you must do to the other. So I've now got to times this side by 5. I need to times 40 by 5, and I need to times this bracket here by 5. So now we've got rid of the fractions, but we have brackets. We need to get rid of the brackets by expanding. So I'll leave the 200 alone because we have to do times before add. So I go negative 5 times x, negative 5 times negative 3. That's how I expanded this one. Now to expand this set of brackets, 4 times x and 4 times 11. So just getting like terms together, 200 plus 15 is obviously 215. So now I have an equation in which I have the pronumeral on both sides. So what I'm going to do is add 5x to both sides, because subtract 5x and add 5x undo each other. I get 215 equals 9x plus 44. So what I do now is I subtract 44 from both sides. So then I get 171 equals 9x. Divide each side by 9, I get x equals 19. And you can check that by substituting here and here for 19 and making sure you get a true statement. All right, let's now look at some inequalities. So to solve inequalities like these ones here, they're inequalities because rather than an equal sign, they have a greater than or a less than sign. We are going to use the same process as we did for equations. So to solve this one here, we're going to subtract 1 from both sides. We get 3x is greater than 15. Then we're going to divide each side by 3. So still the same rule applies. What you do to one side, you must do to the other. We want to get x by itself. So we get x is greater than 5. That means any number greater than 5 is a solution. X equals 6, is a solution. X equals 7, x equals 8, x equals 200. Any number more than 5, if substituted for x, will make this a true statement. So to show the solutions, we draw up our number line, which goes forever in both directions. We'll put 5 here. So we're going to draw a line that starts at 5 and points to all the numbers greater than 5. Now, if we don't include that value, you use an open circle. Open circle means it's either greater than or less than. But we use a shaded circle if we're including the values, if it's greater than or equal to or less than or equal to. So this means all the numbers greater than 5, not including 5, are solutions. All right, let's look at this one here. So 10 minus 2x is less than or equal to 0. So what we want to do is get x by itself. So we're going to start by subtracting 10 from both sides. Now, what we have to do to get x by itself is divide each side by -2. So this note here says when we have to divide or multiply each side by a negative, we reverse the inequality. So we get x, and -10 divided -2 is 5, but we have to reverse the inequality because we divided each side by a negative. So when I'm drawing up the number line, this time any number greater than or equal to 5 is a solution. So to plot this on a number line, it's going to look the same as the last one, except I shade in the circle because this time 5 is included. All right, how would I solve this one here? Well, the same way as an equation. If x is on both sides, we're going to subtract the one with the lowest coefficient. And of course, subtracting -2x is the same as adding 2x. So I get 5x minus 5 is greater than or equal to 10. Add 5 to both sides. And then divide each side by 5, I get x is greater than or equal to 3. So here we have a nested inequality. We can just perform these simultaneously. So to undo subtracting 2, I'm going to add 2 to this side. And I'm also going to add 2 to this side. I get x is between, this is how we read it, x is between, not including -2 and 10. So to show this on a number line, we have -2 here, so 0 would be about there. We're not including -2 or 10, so open circles, and we just draw a line between them. All right, let's now look at some worded problems. So when you have to use equation solve a worded problem, define the variable. That means let x be whatever you're trying to find. Then you form an equation and solve. So a maths tutor charges $70 per hour plus a $40 call out fee if the tutor charges $250 for how many hours did they work. So what we want to find here is the number of hours. So we let x equal the number of hours. That's step 1, defining the variable. So step 2 is to form an equation. What we're going to do is rewrite all of this information using only mathematical symbols, no words. So what we have is the tutor gets $70 per hour, which we write as this, 70 times the number of hours, plus the $40 call out fee gives $250. So to solve this equation, we subtract 40 from both sides. So we get 70x equals 210, and we divide each side by 70. So dividing each side by 70 gives us x equals 3. But we're not quite done. You need to say what you found. You don't need to write an essay, so you just say something like therefore needs to, as in the tutor needs to work for 3 hours. So if the tutor works for 3 hours, they'll earn $250. Let's now look at a harder worded problem. So perimeter of a rectangle 44 centimeters, length is 12 centimeters more than the width. Calculate the dimensions of the rectangle. So in this case, we are trying to find 2 things. We need to find the length and the width. When you have to find multiple quantities, you need to use the same variable to define each. What does that mean? So step 1, define variable. We're going to let x equal just one of the things we're trying to find. So I'm going to let x equal the width. Now I need to write the length in terms of x, but I can't use a different pronumeral. I can't use a different letter or variable. We don't know how to solve equations with two variables. So what we're going to do is write the length in terms of x. If the width is x and the length is 12 centimeters more, the length is just whatever the width is plus 12. I've used the same variable, the same pronumeral to define each quantity. So now step 1 is done. We can do step 2. We can form an equation. So the perimeter of a rectangle is 2 times width plus 2 times length. That's the perimeter, and we're told that equals 44. So to solve this equation, we need to get x to one spot. So we're going to expand the brackets, 2 times x, 2 times 12, and now we're going to collect like terms. 2x plus 2x is 4x. So now that x is in only one spot, we can solve by undoing what's been done to x in the opposite order to BIDMAS. So what you do to one side, you must do to the other. We get 4x equals 20. We undo timesing 4 by dividing by 4. So we get x equals 5. So now we need to write what we found. You don't need to write an essay, but we said x was the width. So the width must be 5 centimeters and the length is 12 more, so it must be 17 centimeters. So we've now said what we have found. We are done. Let's move on to an even harder example. So I am 8 years older than my brother. In 9 years' time, I will be twice as old as he is now. How old is each of us? So here we're finding two things. We're finding number 1, my age, number 2, my brother's age. So let's let x be one of the quantities. I think it's easier to let x be the smaller quantity. So I'm going to let x equal brother's age. So if my brother is x and I'm 8 years older than him, my age is x plus 8. I am whatever my brother is plus 8. So we have defined the variables. We have used the same pronumeral in each. Second step, form an equation. So in 9 years' time, if my age is x plus 8, in 9 years' time, it will be x plus 8 plus 9. So, of course, x plus 8 plus 9, I can simplify as x plus 17. That's going to be my age in 9 years' time. Now, it says I will be twice as old as he is now. My brother is x, so twice as old as he is now is 2x. I get x plus 17 equals 2x. Subtracting x from both sides, because this is the one with the lowest coefficient, I get 17 equals x. So that means brother is 17. He's currently 17. My age is 17 plus 8, which is 25. So we've answered the question and we're done. All right, that's all for the mainstream part of the video, but if you'd like to keep tuning in for the LEAP video, please. Otherwise, best of luck with your test. So in the LEAP class, we also looked at rearranging formulae. So we are going to use the same principles for equations as we do for rearranging formula. So we need to be able to do ones like this. 3x minus 4y equals 24. We need to make y the subject. So to get y by itself, which is what make y the subject means, I need to undo what's been done to y in the opposite order to BIDMAS. So 3x here is just a constant like a number. So I'm going to undo adding 3x by subtracting 3x. So I then get negative 4y equals 24 minus 3x. So now to get y by itself, I need to undo timesing negative 4 by dividing each side by negative 4, because times negative 4 and divide negative 4 undo each other. So there they will cancel out. I'll be left with y equals. Now I need to divide everything by negative 4. 24 divide negative 4 is negative 6. Negative 3x divided by negative 4, it's going to become a positive. I'm just going to write it as 3/4 x. That's my final answer and we're done. All right, now I'm going to take this formula here and make x the subject. So this is a formula because it has more than one pronumeral and one of them is the subject. Y is currently the subject. I want to make x the subject. So I'm going to get rid of the fraction by multiplying each side by x minus 1. So I get y side of x minus 1 equals x plus 1. So I want to get x by itself, so I'm going to need to expand the brackets. Y times x, y times negative 1. Now I need all the x's back on one side of the equation and everything else on the other. So what I'm going to do is I'm going to subtract 1 from both sides, and I'm also going to subtract xy from both sides. So if I do that, I get negative 1 minus y on the left hand side. I get x minus xy on the right hand side. So to get x by itself, the problem is I need x in one spot, but it's in two spots. But I can easily get around that by factorizing. So I've got negative 1 minus y on the left-hand side. I can factorize this by taking out a common factor of x. So x times 1 equals x times negative y gives you this term. Now that I've done that, I can simply divide each side by 1 minus y. So I get negative 1 minus y over 1 minus y equals x. Now it may look like this can be simplified, but it can't. You can't cross out the y's because they're not being multiplied. We have to leave it like that. We are done. All right, let's now look at a non-linear equation. So previously in the video, we've looked at solving linear equations where there's no power of x. Now we're going to solve this equation that is non-linear. It's non-linear because of this power of x. But we're going to use the same principles as for equations. So we have 4 over 3 x cubed. I want to undo timesing by 4 over 3 by dividing by 4 over 3. And again, what you do to one side, you must do to the other. 4 over 3, divide itself just is 1. They undo each other. I'm left with x cubed equals, now 100 divide 4 over 3 is 75. So I've got x cubed equals 75. I want to get x by itself. So how do I do that? Well, we undo cubing by cube rooting. So I can cube root this side as long as I cube root the other. So cube root of x cubed is x. I just get x equals the cube root of 75. And if you put that on your calculator, you get x is about 4.217. It's not a whole number. In fact, it's an irrational number. But don't assume just because the answer is not a whole number that it must be wrong. All right, thank you so much for tuning into this video. Best of luck studying for your test, but I'm sure you're going to ace it. This has been the luckiest maths teacher in the world. Have a great day.